Good afternoon. Welcome to Raaonline. Today's class is about eyeball. The other terms used for eyeball are oculus, which is a Latin term. It is also named as ophthalmos. It is the Greek term, and then the globe of eye. So this is the sagittal section of the eyeball, which has three coats present within it. Eyeball is compared to camera. You can understand this at the end of the class, why the eyeball is compared to the camera. So introduction to eyeball. Eyeball is spherical or globular in shape. Its diameter is around 2.5 centimeter. It is located within the orbit. The whole thing is the orbit. So it occupies the anterior part of the orbit and it is embedded in fat. Here you can see an yellow structure, that is the fat, and that gives a cushion to the eyeball. It is enclosed within a sheath called Tenon's capsule. There are three layers in the eyeball. It is present one within the another. The outermost coat is the fibrous coat called as, which contains sclera and cornea. The second coat, middle coat or vascular coat or uveal tract, which contains choroid, ciliary body and iris. And the third coat is the inner coat or nervous coat, that is retina. Now let's see one by one. This is a transverse section. This outer coat is the sclera. The sclera continues anteriorly, and this is cornea. The second coat, which is pale red in color, is the choroid. The choroid, it continues anteriorly, and this portion is the ciliary body, and anteriorly this is iris. So these three structure forms the second layer of the eyeball. The third layer is the nervous coat, which is represented in yellow color, that is retina, which is the nervous layer of the eyeball. So these are the three coats present in the eyeball. First, let's see the outer coat. The outer coat contains sclera and the cornea. First, I'll discuss about the sclera. The sclera or white of the eye. Since it is white in color, it is the white of the eye. So this outer layer is the sclera. It is opaque. It occupies posterior 5/6 of the outer coat of the eyeball. So this layer, which is white in color, I am tracing. So this forms the posterior 5/6 of the eyeball, and it is covered by a fascia called as Tenon's capsule. The Tenon's capsule separate the eyeball from orbit, bony orbit. The inner surface is brown because of the choroidal layer, and it is grooved by ciliary nerves and vessels. This sclera, it anteriorly continues with cornea, and this corneoscleral junction, this area, this corneoscleral junction is called as limbus. So this is the posterior end of the sclera. Here it is a section taken at the level of limbus. So this is sclera, and this portion is cornea. Here this area is the limbus or the corneoscleral junction. There are two important structures present closer to limbus. One is canal of Schlemm or sinus venosus sclerae. Here a round canal, a slit-shaped canal that is present just behind the limbus is the canal of Schlemm. Next is scleral spur. Here this is a magnified view of the Schlemm's canal. Here you can better see the Schlemm's canal. This is the Schlemm's canal. It is an outlet for aqueous humor. And here you can see the another structure called scleral spur. So this is scleral spur. The scleral spur is a triangular projection which projects forwards and inwards. See here, this is a scleral spur, this is a limbus region, so it is projected forwards and inwards, and it gives attachment to ciliary muscle, which is a part of uveal tract. So this is ciliary muscle, and this scleral spur lies posterior to canal of Schlemm. Now let's see what are the functions of the sclera. It is an outer coat. So the outer coat gives protection to the eyeball. It helps to maintain the shape of the eyeball, and it also provides attachment to extraocular muscles. Posteriorly, this is the posterior view of the sclera where you can see the 4 quadrants. Posteriorly, this sclera, it continues with dural sheath of the optic nerve. The sclera thickness, it is thinnest at equator. Since eyeball is like a ball, it is thinnest at the equator, it is thickest at the back, but it is weakest at the site of exit of the optic nerve. So that portion of the sclera is called lamina cribrosa, because this layer, it has so many openings through which neurovascular structures enter the eyeball. Here you can see, this is the optic nerve, okay, and it is covered by a dura mater, and around the optic nerve you can see small twigs. These small twigs are the entry of the short ciliary arteries, the short posterior ciliary arteries, and also short ciliary nerves enter along with the short ciliary artery around the optic nerve. In addition to that, long posterior ciliary artery, here you can see the long posterior ciliary artery, the anterior ciliary arteries, and 4 vortex veins. Here you can see the 4 vortex vein for each quadrant. This is one vortex vein, this is one, this is the second vortex vein, third and fourth. So these are the venous drainage of the eyeball. So these are the structure piercing the sclera. They are optic nerve, long posterior ciliary artery, short posterior ciliary artery and nerve. This is the short posterior ciliary artery, and the yellow color structure is the short ciliary nerve, and 4 vortex vein from each quadrant of the eyeball. Now let's go to the next part of the outer coat, that is cornea. This is cornea, which is a transparent structure. It is transparent because it is avascular. It is not supplied by any blood vessels. It occupies anterior 1/6 of the eyeball. It is more convex than sclera. Here you can see, this is the cornea. So here the anterior convex portion is the cornea. The space between the cornea and the iris, this is the iris, this muscular part is the iris. So in between these two, there is a chamber called anterior chamber. AC represent anterior chamber. The cornea is a avascular one, but it is rich in nerve supply. It is supplied by branches of ophthalmic nerve and branches of short ciliary nerve. Since it is rich in nerve supply, if there is any aberration in the corneal epithelium, it is very painful. It is nourished, since it is avascular, but it derives its nutrition from oxygen, that is external atmospheric air, whereas the inner layer of the cornea receives the nutrition from aqueous humor that is present in the anterior chamber of the eyeball. Now let's go to the histology of the cornea. Cornea is a transparent layer which contains 5 layers. The outer layer is the epithelium. It is a non-keratinized stratified squamous epithelium which shows the multiple layer of the nuclei, and the next is Bowman's membrane. Underneath the epithelium there is a homogeneous layer, that is the Bowman's layer. Substantia propria. The substantia propria is nothing but stroma. The other term for the stroma is substantia propria. And the fourth layer is the Descemet's membrane, and the innermost layer is the endothelium. So these are the 5 layers of the cornea. Now let's go to the second layer. So what are the structures you saw in the first layer? The posterior 1/6 is formed by the sclera and the anterior 1/6 is formed by the cornea. Now let's go to the second layer. The inner layer, inner to the sclera, that is a second layer called uveal tract. It is the middle coat. This uveal tract contains 3 subdivisions. The posterior most part, which is corresponding with the sclera, is the choroid. The black line represents the choroid. Okay, and then here you can see anterior to the choroid is a muscle layer called as ciliary body, and then anterior to it is a projection of another muscle layer called as iris. So these are the 3 parts forming the uveal tract. From posterior to anterior, first is choroid, next ciliary body, and the third one is iris. This is posterior to anterior. So let's see one by one. First, let's see the choroid. So choroid forms the posterior part of the middle coat. It is a thin pigmented layer. Because of the melanin pigment, it is black in color. Anteriorly, it ends in ora serrata by merging with ciliary body. This is a ciliary body. And posteriorly, it is perforated by optic nerve. So choroid, it derives its blood supply from the short ciliary arteries. These are the short ciliary arteries. This is a vascular coat. They have removed the sclera. This is sclera. They have removed the sclera. And what you are seeing is the vascular coat of the eyeball, that is a choroidal layer. This is the optic nerve. Which surrounding the optic nerve, it is an entry of so many short branches. They are short ciliary arteries. They are branch of ophthalmic artery. So these short ciliary arteries, they pierce the sclera around the optic nerve. The veins in the vascular coat, the veins are arranged in the form of whorls. They converge and form a single vein called as vortex vein or vena verticosa. There are around 4 veins. Here we have exposed only 2 veins. This one pierces the sclera and just behind the equator to open into the ophthalmic veins. So finally, the 4 vortex vein drains into ophthalmic vein. So the choroidal layer contains only arteries and veins. In addition to that, there is a pigment called melanin pigment, which gives the dark coat to the choroid. So let's see the histology of choroid. It consists of 4 layers. This is the outer sclera. We are going from outer. So this is outer sclera and this is the inner retina layer. Let's see one by one. This outer coat, first layer, is the suprachoroidal lamina or a lamina fusca. It contains the collagen fibers. And then the next layer, this layer is the stroma. So the stroma contains both large blood vessels as well as the small vessels. So that forms the second layer. And the third layer contains capillaries called as choriocapillaries. And the last one is the Bruch's membrane or the basal lamina. Here it is represented in sky blue color. Here you can see. So this is the Bruch's membrane. So these are the 4 layers of the choroid from outer to inner. Now let's go to the middle portion of the uveal tract, that is ciliary body. This ciliary body lies posterior to the corneal limbus. Here you can see this is a section, hemisection. This is cornea, this is sclera, and this portion, this area is the limbus. This part, the whole thing is the ciliary body. Here in the ciliary body, this lies posterior to the limbus and it continues posteriorly with the choroid and anteriorly with the iris. So, this is the iris. It is triangular in cross section. So, this is the apex and this forms the base. So, it is triangular in cross section and the scleral surface contains ciliary vessels. So, this ciliary body is again subdivided into three parts. The outer layer is called as the ciliary ring. This is the location of the ciliary ring. And then ciliary muscle. Here you can see two type of muscle. One is longitudinal muscle. Here you can see this is longitudinal muscle and this bundle is the circular muscle of the ciliary group. And then there is a projection. There is so many processes projecting from the ciliary body. These are called ciliary process which secretes the aqueous humor. So, this is a posterior view. We have cut the eyeball at the level of the equator and we are seeing the eyeball from behind. What you are seeing in the center is the lens of the eyeball and surrounding it, this is the choroidal layer, anterior part where you can see the ciliary body. In the ciliary body, this is the ciliary muscle and you can see so many processes. The white color structure is the ciliary processes. So, the posteriormost part, the choroid, the ciliary body which contains the ciliary muscles and the ciliary process. So, in cross section, as I already explained, it is triangular in shape. It consists of two parts, pars plicata and pars plana. So, what is pars plicata? Pars plicata is nothing but ciliary process. It is a finger-like, here you can see it as a white finger-like processes present, that is called ciliary process, and it is surrounded by a smooth brown area, that is the base of the iris, which forms the posterior smooth part of the ciliary body called as pars plana. Since it is smooth, it is named as pars plana. Since it has irregular processes, the ciliary process is called pars plicata. Now, let us go to the ciliary process. Let us see what is present. This is the half section of the eyeball where we are focusing on the anterior chamber and the ciliary body with the iris, and this is magnified view of the ciliary body where you can see so many processes projecting. These worlds wave-like processes. These processes are called ciliary process. These are ciliary process. There are around. This is the ciliary muscle. There are around 70 to 80 radial folds seen. Here you can see there are around 70 to 80 ciliary process throughout 360° present, and in between the process there is a deep surface or the groove. This is one process. This is another process. So, in between the process there is a groove, this groove. In this groove, it gives attachment to, you can see a faint white color thread-like structure. They are nothing but suspensory ligament of lens which is anchored from the lens capsule to the groove between the ciliary process. So, this groove gives attachment to suspensory ligament of lens. The function of this ciliary process is to secrete the aqueous humor which gives nutrition to the anterior segment of the eyeball. And the third one is the ciliary muscle. So, as already seen, this is the ciliary muscle. This portion is the ciliary muscle. This ciliary muscle has two parts, longitudinal fibers and circular fibers. So, this radially arranged muscle, this is a longitudinal group of muscle, and this is a cut portion of the circular fibers of longitudinal muscle. This is longitudinal fibers. The longitudinal fibers, they arise from scleral spur. So this is the scleral spur as already explained. This is a canal of Schlemm. Posterior to that, this projection is the scleral spur. So from this scleral spur, the longitudinal fibers of the ciliary muscles, it takes origin. They are obliquely placed and it gets continuous with the circular fibers. The circular fibers, it is an anterior part of the ciliary body. When it contracts, since it is attached to the base of the ciliary process, when it contracts, it relaxes the ciliary ligament of the lens and the lens will become more convex during accommodation. So the function of this ciliary muscle is to focus the lens for the near vision. Next is iris, the anterior-most part, which here you can see the brown color structure. So it is an anterior-most part of the middle coat called the uveal tract. So this is the iris. The circular curtain, that is, it is a half portion of the iris seen. There is another half present on the other side. So a circular curtain opening in the middle of the iris is called the pupil. It acts like a diaphragm. It controls the amount of light entering the eye, and it is the contractile diaphragm that lies between cornea and the lens. So this is cornea and this is lens. So this iris divides this segment, anterior segment, into two. One is in front of the iris is the anterior chamber, and portion that lies between the iris and the lens is the posterior chamber. So this is the posterior chamber and this portion is the anterior chamber of the eye. The color of the iris is determined by number of pigment cells present, that is the melanin cells present within the connective tissue layer. It contains sphincter pupillae and dilata pupillae. Let's see what are the muscles. This is a different layers of the iris muscle. This is a melanin pigment seen. After we remove that epithelium, this is a muscular coat and this is a vascular coat of the iris, which is supplied by two arterial arcades, major and minor arterial circles. So this is a minor arterial circle and this is a major arterial circle, and this is muscle coat. So it contains two type of muscle. A muscle layer which is closer to the pupillary margin is the sphincter pupillae. When it contracts, it acts like a sphincter and controls the amount of light entering the pupil. And the next one, which is radially arranged, is the dilata pupillae, which dilates in the dull light. The nerve supply of this iris muscle, sphincter pupillae, is supplied by postganglionic parasympathetic fibers from ciliary ganglion, whereas the dilata pupillae is supplied by postganglionic sympathetic fibers from superior cervical ganglion. What is the function of the iris? Since it forms a central pupil, it controls the amount of the light entering the eye through the pupils. Now let's go to the inner coat, which is yellowish in color, that is retina. The inner layer of the eyeball is called retina. It contains two layers. The outer pigmented layer, which is closer to the choroid, and the inner yellowish in color is the sensory layer. Here this portion is the retina. Opposite to the entrance of the optic nerve, there is a circular area. This area is called optic disc. So this area is the optic disc layer in the retina. It is divided into two parts, optical part and ciliary and iridial part. The optical part is sensitive to light, whereas the remaining portion is insensitive part, that is called ora serrata. So let's see what is blind spot. It is a depressed area of the optic disc which contains no rods and cones. So this point where the optic nerve emerges out from the retina, this area where you don't contain the rods and cones. So this portion, since it doesn't contain any pigment, it does not observe the light. So this part is called blind spot of eye. The rod cells present in the retina usually respond to dim light and the cone cells will respond to bright light. So let's go to the area of the retina where there is no pigments present. They are called ora serrata. Since it is like a serrated margin, here you can see as already this is a magnified view of the ciliary muscle, and at the closer posterior part, here you can see a projection which is tooth-like projection, and this part is the ora serrata. This is the ora serrata, which here it is represented in yellow color. These ora serrata dips in between the ciliary muscle and it gives a dentate process or a tooth-like extension. So it's a tooth-like extension of the retina on the pars plana. So this is pars plana, and the projection is called as pars plicata or ciliary process. Okay, so it is located 6 to 8 millimeter away from the equator and 25 millimeter from the optic nerve. So these tooth-like projection, which is devoid of pigment layers, is called as ora serrata.